Okay, our second lesson in the parallel and perpendicular lines units deals with angles and parallel lines. So a lot of this you have seen before in middle school, which is nice. It's nice when what we're talking about matches up with information you've previously learned. So our essential question is, what angle relationships are formed when parallel lines are cut by a transversal? So everything we're talking about today, we will have parallel lines. So important to have parallel lines cut by a transversal. So let's see here. Let's do a couple of parallel lines. I'm going to mark them parallel. I'm going to stick a transversal in here. And let's go ahead and number these. 1, 2, 3, 4, 5, 6, 7, 8. A bunch of vocabulary words today. If two parallel lines are cut by a transversal, then your corresponding angles are congruent. And this is called the corresponding angles postulate. Now, when you make your note card for this postulate, you should start with the if. If two parallel lines are cut by a transversal, then corresponding angles are congruent. Okay. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. And this one is called the alternate interior angle theorem. So when you make this note card, you want to say, if two parallel lines are cut by a transversal, then alternate interior angles are congruent. If two parallel lines are cut by a transversal, then alternate exterior angles are congruent. Very creatively called the alternate exterior angles theorem. Again, when you go to make this note card, make sure you have the if-then statement for your definition. And finally, consecutive interior angles or same side interior angles are supplementary. This one's the oddball. This is the one that's different, right? And this is called the consecutive interior angles theorem. Again, as you make this note card, make sure you write the if-then statement. There is a consecutive exterior angles theorem, but we hardly ever use it. And it also says the angles are supplementary. Don't forget that your vertical angles are congruent and your linear pairs are supplementary. Right? Vertical angles are congruent because of the vertical angles theorem, and linear pairs are supplementary because of the linear pair postulate. You did note cards on both of those. Back in Unit 1, you might want to dig those out and put them in your stack to review. Okay, so given the measure of angle 6 is 142 degrees. All right, before I do anything else, right, I'm focusing in on this information and I'm going to annotate it on my diagram. So angle 6 is 142 degrees. Super important. Find the measure of each missing angle and name the angle relationship. Okay, angle relationships I can do no matter what, but before I can start doing measurements, I really need parallel lines. Alrighty, sure enough, we do have parallel lines up here, and so I'm going to take my highlighter and highlight my parallel lines. I'm going to take my marker and go over the transversal, right? Now, let's see. I don't have to go in any particular order, but I know 6 and 8 are corresponding angles. So the measure of angle 8 has to be 142 degrees. I'm going to annotate my diagram. Make sure when you write this down on line G, you're including the degree sign. And these are corresponding angles. Okay, 6 and 1 are vertical angles. So this is 142 degrees also. I could have also said 1 and 8 are alternate exterior angles, so I could have a different angle relationship there in part A. Let's see. 1 and 3 are corresponding angles. I can go ahead and mark 142 degrees for 3. And I'm going to go ahead in here and say that I was talking about angle 1 for that relationship. Vertical angles, I'm going to say I was talking about angle 6. And down here for angle 8, I'm going to remind you I was talking about angle 6. Okay, I need the other 4. Well, let's see. 5 and 6 make a linear pair. So 180 degrees minus 142 is 38 degrees. Linear pair with angle 6. And now I've opened up all kinds of possibilities, right? I could fill in angle 2, it's vertical. It's a vertical angle with angle 5. I could say it's a linear pair to angle 6 or to angle 1. Angle 7 has to be 38 degrees. I'm going to say it's consecutive interior with angle 6. I could say it's alternate interior to angle 2. Right? So I've got options here on what I do. And angle 4 is 38 degrees. Oh, let's see. Let's say that's alternate exterior with angle 5. So for the angle relationship, you have options. It all depends on what angle you're partnering up with. It's really helpful if you name the angle you're partnering with so that the person looking at it knows what you're thinking. Ooh, I like it. I like it. I like it. All right, so I'm given, right, the measure of angle 5 is 82 degrees. Let me annotate that right away. Angle 5 is 82 degrees. Now, find the measure of each missing angle, and I am seeing 1 2, 3 parallel lines to highlight, and 1 transversal to go over with my marker. All right, I want you to pause the video and fill in all of these angle measurements. Okay, check your work. At half a point for each degree sign, you could lose a lot of points on this problem. 1, 2, 3, 4, 5.5 points off of a test or a quiz just by not putting the degree signs after all of these angle measures. So be careful with that notation, ladies and gentlemen, because you know it's going to cost you. Look at this, an even more complicated diagram. All right, we start off with a given that angle 12 is 121 degrees and angle 6 is 75. So angle 12 is 121 degrees and angle 6 is 75. I'm going to annotate that immediately. When I went to annotate that, I noticed some parallel lines here and here. The other 2 lines up here are transversals. I'm going to do one in red, and I'm going to do the other in green. Okay, and now I need to start having some fun. So, let's see here. Let's start with angle 6 and see what that helps me figure out right away. Well, angle 6 and angle 1 are both vertical, so angle 1 will be 75 degrees. Angle 6 and angle 9 are alternate interior, so angle 9 is going to be 75 degrees. 9 and 14 are vertical, so 14 is 75 degrees. I think that's as far as I can go with that. Okay, let's look at the 121 degrees. Let's see, angle 7 is vertical, so that's 121 degrees. Angle 7 and angles 5 and 6 together would equal 121 degrees. They'd be alternate interior. So 121 minus 75 is going to be 46. Let's see, angle 5 is 46 degrees. Good to know. Ooh, angle 2 is vertical, so that's going to be 46 degrees. Let's go back to that 121. Okay, we've got the corresponding. I think we've got everything there we can do flat out with 121. So now let's look at some linear pairs. Okay, let's see. 75, 46, and angle 3 all have to add up to 180. So 180 minus 75 is 105 minus 46. I've got 59 degrees for angle 3. And vertical to angle 3 is angle 4, 59 degrees. Let's see, 120 degrees plus angle 8 has to equal 180. That makes this one 59. Angle 8 is 59. Angle 11 is vertical, so that will be 59 degrees. Okay, 75 degrees and angle 10 have to be supplementary. So angle 10 is 105 degrees. And so is angle 13 because it's vertical with 10. These just become a giant puzzle, and I really enjoy that. Ooh, a little algebra to have some fun. Okay, we're solving for x and y. And as I look at my diagram, I immediately note that I have parallel lines here. I have a transversal right here. So if I look for the angle relationship here between the 135 degrees and the 3x plus 15, they are corresponding. And I know that corresponding angles are congruent when I have parallel lines. So 135 equals 3x plus 15. Subtract 15 from both sides and divide by 3. X equals 40 for this first problem. I want you to pause the video and I want you to try both of these problems. Make sure that you name the angle pair relationship so you're thinking about that before you actually try to solve. Okay, check your work. For the first one here, it doesn't come out a whole number. And I'm okay with the decimal because it was a terminating decimal. If you have 0.5, 0.8, 0.2, that's all great. If it's a repeating decimal or if it's an irrational number, you would have to leave your answer as a fraction. So if you can't give me an exact answer, I want a fraction. If you can give me an exact decimal, I'm okay with the decimal. All right, so question that often comes up, and just a reminder back from Unit 1. Okay, what is the difference between postulates, theorems, and corollaries? We saw postulates and theorems in today's lesson. We're going to see corollaries later in this unit. But postulates are accepted without proof. They're the building blocks. They're the things that mathematicians all agreed we would accept as true, even though we have no way to prove them. Okay. Theorems are provable. And corollaries are easily provable. It just takes one, two, or three, sometimes even one, step away from a theorem. Now you saw postulate and theorem as vocabulary words back in Unit 1. I don't remember us doing corollaries, but you either need to pull out those note cards to include in this unit, or you need to make new note cards. All right, I want you to write a summary. And the most important part of this particular lesson was that these conditional statements were true only when we had parallel lines. So be sure you include the fact that you have to have parallel lines before you can start talking about measurements relating to each other with the angle pairs.